My name is Danko Emmanuel Kenjo, and I officially welcome you to Kentech 96 TV. For today's lesson, we'll be diving deep to what we call Venn diagram. Now, Venn diagram is a widely used diagram used to display or illustrate the relationship between two or more data sets. They are also used to display the similarities and differences between two sets. So let's look at the definition of Venn diagram. Then once we are done with the definition, we look at how to apply Venn diagram in solving a data set. Okay, so a Venn diagram is a type of graphical organizer which is used to display similarities, differences between two or more sets. So when we talk of a set is a collection of data. Now, when we talk of Venn diagram, we have what we call circles. And the circles are used to represent each set. So in case you are having two data sets, it means you'll be having two circles. And this is what we call two-set problem. And if you have three circles, it means we are talking of three data sets. So that one, we have 1, 2, 3. And this is what we call three-set problem. So for this lesson, we'll be looking at three-set problem. So circles are used to represent each set, and any properties in common to both sets will be written in the overlap. So when you have, let's say, the circles, this is two sets problem. You see, this is circle number 1 and this is 2. And here is the overlap. First circle overlaps the second circle. So here, this is where we write elements belonging to sets 1 and 2. So here, both circles are used to represent each set, and any properties in common to both sets will be written in the overlap of the circles. Any property unique to a particular set is written in the circle alone. So once you've written what is common to both circles, what is now unique, the one which circle 1 has and 2 does not have, that is what we write here. Now, the circles are used to compare and contrast three categories. Remember, I said we are looking at what we call three sets problem. Each circle represents different categories. So if we are talking of, let's say, football, hockey, and basketball, it means we are having three categories, and we are supposed to represent them with three circles. A Venn diagram with three circles is called triple Venn diagram. So another name for three sets problem is what we call triple Venn diagram. So let's look at how to solve question with Venn diagram. How to solve question with three sets how to solve three sets problem with a Venn diagram. So let's look at how to make a Venn diagram with three circles, which is what we call three set problem. First, write the number of items belonging to all the three sets. So for three sets problem, we are going to have three circles. So 1, 2, 3. Then you have what? A box around the circles. Then please be mindful whenever you are using drawing Venn diagram. Remember, if we are talking of hockey, we are going to represent here as, let's say, H. If it's football, here will be F. If ampere, here will be A. So before you start, you need to declare your variables. Let H represent, let's say, students who play hockey. Let A represent students who play ampere. Before you start, you cannot just draw the circles and represent them as H, F. What does F stands for? You need to first tell us that, oh, let F represent students who play football. So if I have my three circles, what I need to do is write the number of items belonging to all the three sets. So always start your Venn diagram from here. So you first write what is common to all the three categories. Then, secondly, write the remaining number of items belonging to each pair of sets in their overlapping region. So 1, remember H and let's say F. This is their overlapping region. So once you are done with the central part, which is the part which is common to all the 3 sets, you move on to the overlapping part between the individual sets. So from here, you can start from this side, and this side. So first start from the central part, then you move on to the overlapping part. Then thirdly, write the remaining number of items belonging to each individual set. So now we want to write what is common to only hockey here. Here you write is what is only common to, let's say, students who play football only. Here will be, let's say, students who enjoy ampe only. So the set which is common to only ampe, that is what we write here. And here is for, it says A is overlapping F. So here will be a set which is common to F and A. So here we talk of A intersection F. So if it's, let's say, a school, this will be students who play both ampe and football. Here will be students who play, let's say, hockey and football, and this side will be hockey and ampe. And this intersection set will be students who play all the various 3 games, or all the 3 games. Okay, so we are supposed to draw a Venn diagram to represent this data. And in the data, we have 30 students were asked which sports they play. 20 play basketball in total, 16 play football, 15 play tennis, 10 play basketball and tennis, 11 play basketball and football. Then 9 play football and tennis, 7 play all the 3 sports. So here I told you first you need to declare your variables. So you need to start, let's say, let U represent students who play, let's say, let U represent the students in the school. So I'm going to have number of U, which is equal to 30. Then let B represent students who play basketball. So number of B will be equal to 20. Then let F represent students who play football. So number of, let's say, F going to have 16. Then let T represent students who play tennis. So number of T is also equal to 15. So now we have 3 categories. So we can represent this on the Venn diagram. So 1, 2, 3. Have your triangle or square here. So now this is where the U is the universal set. So here number of U is equal to 30. That is the students, let's say, in the school. Then this will be our B. So this whole circle is for basketball. Then we can have football here. Then lastly, tennis. Now, if you want to solve 3 set problem, first what you need to do is to first solve or look for the central part, the overlapping part, which is common to all the 3 categories. And here is for students who play all the 3 sports. So here is 7. So you put 7 here. Then you move on to this, either here or here or here. So this is T, F and T. So students who play both football and tennis. Football and tennis. So here we have football and tennis, which is 9. So football and tennis, 9. You subtract 7 from 9, you have equal 2. Then this is basketball and football. So for basketball and football, we have 11. If I take 7 out, to be left with 4. Then this is basketball and tennis. Basket, which is 10. and I will take 7 out, it will be left with what? 3. So there's 3 represent students who enjoy only basketball and tennis. Now, I'm left with this portion of the circle, and this side is for students who enjoy basketball only. This is for students who enjoy tennis only. This is for football only. So you need to sum this together. Then you subtract from the total. That is what you have here. So for basketball, the total is 20. So if I want to know the students who enjoy basketball only, it's basically going to be 20 minus 4 minus the sum of 4 plus 7 plus 3. So 20 minus 14, which is 6. So 6 students enjoy basketball only. Then football, the total number is 16. So it will be 16 minus the sum of 4 plus 7 plus 2. So this plus this 11, 13, 3. So 3 people enjoy football only. Then for tennis, the total is 15. So if I want to sum 15 minus the sum of 3 plus 7 plus 2, which is 12. 15 minus 12 is going to be 3. So it means that 3 people enjoy tennis only. So let's take another question and for you to understand Venn diagram or 3-set problem. So for example 2, a survey from faculty and graduate students at Kendall's University revealed the following. 51 students like applied electricity. 41 students like linear algebra. 60 students like research methods. 34 like applied electricity and linear algebra. 32 like algebra and research method. 36 like applied electricity and research method. 24 like all the 3 subjects. 1 dislikes all the 3 subjects. How many students were surveyed from the university? So to start this, you should know that we are going to apply what we call Venn diagram. So in solving this type of question, we need to first declare our variable such that we will let U represent the total number of students that were surveyed from the question we were not given. Then we let A represent students who study applied electricity. So we can have number of A representing applied electricity, which is equal to 51. Then we let L represent students who study algebra. So we are going to have number of L students who study in algebra as 49. Then let R represent students who like research method. So number of R will be equal to 60. So then we have 34 like applied electricity and algebra. So number of A intersection L, that is students who enjoy both applied and algebra, which is equal to 34. Then we have number of students who enjoy algebra, linear algebra and research method. They are equal to 32. Then we have students who enjoy applied and research method, which is equal to 36. Then 24 students, number of students who like all subjects, so number of students that are interested in applied linear algebra and research method is equal to 24. And number of students who do not enjoy or like any of the subjects is 1. We have this to be equal to 1. So let's use Venn diagram to find the number of students that were surveyed. Okay, so we have three categories, which is applied electricity, linear algebra, and research methods. So definitely we are going to have three sections. So 1, 2, 3. Then we have our square here. Then this is where we write the number of students that were surveyed. We don't have that. Then we have what we call A, representing applied electricity, L, representing linear algebra, and R, representing research method. Like I said, if you want to tackle any Venn diagram question, you should consider the central part of the overlaps. So here is for students that study all the three subjects, and we have what we call 24 students study all the three subjects. This is for applied electricity, and the number of students that study applied electricity here is 51. The number of students that study applied and research method, so A intersection R, which is 36. So I'll take 24 out of 36 and I'll have 12. Then here is A intersection L, so students that study applied and linear algebra, which is 34. Which is, yes, 34. So if I take 24 from 34, have 10. Then this is for students who study linear algebra and research method, which is 32. So if I take 24 out, I'll be left with what? 8. Then any other part, which is not any, so here, 1 dislike all the three subjects. So normally, you don't add 1 inside the circle. It can be written anywhere outside the circle, but it should be inside the box. So I'll put my 1 here. These are the students that do not like any of the subjects. 1. Now, this is the area for students that like applied electricity only. So I need to add this to this to this, then subtract from 51 to get it. So 10 plus 24 is 34, plus 12 is 46. So 10 plus 34, 46, then 51. I'm going to have 5 here. Then this is L. So 10 plus 24, which is 34. 34 plus 8, which is 42. And 42 minus student that study linear algebra is 49. So I'm going to have 7 here. Then finally, L here is 49. Then R is 60. So I need to sum this and subtract from 60. So 12 plus 8 is 20. 20 plus 24 becomes 44. 44 minus 60 becomes 16. So it means that 16 students study only or like only research method. Okay, so to calculate for the number of students that were surveyed from Cambridge University, you are going to sum all the variables in and outside the circle. So to get that, you are going to have 5 plus 12 plus 10 plus 24 plus 7 plus 8 plus 16 plus 1, which is, so this plus this 17, 27, which will equal to 83. So what it means is that 83 students were surveyed from Cambridge University. Thank you for watching Kentech 96 TV. Please, if you are new to this channel, kindly subscribe and recommend for others. Thank you.